Welcome to this session. Here in this session, I am going to present a meaning of switchgear and essential features of switchgear and a type of switchgear equipment. Now, before going to this session, I will brief about why we need a switchgear. First, we will see with the increase in demand of the electrical power system as the civilization as the modern civilization, because of the modern civilization, we need an increase in the power system, increase in the electricity demand. Therefore, because of increase in electricity demand, there is a increase of large power system network, and there is a more generating stations that are present in the network. Because of this, we have to take care of these power system network and also generating station, so that it should not be affected from the fault condition. It should be in a safe condition. Because of that, we are using a switchgear. Switchgear equipments are those which will protect, control and switching of the electrical circuit and equipment, and this switchgears are protect the electrical equipment under faulty condition. Next we will see about what do you mean by a switchgear. Here at the middle there is a one equipment. This equipment may be a generator or a distributor or a transformer or a transmission line. This equipment or a electrical circuit is switched, controlled and protected by a switchgear. Next, in order to do controlling, protecting and switching, there is a feature for a switchgear. Those features are complete reliability, absolutely certain discrimination, quick operation, provision for manual control and a provision for instrument. Let us see one by one, that is the features of a switchgear. Completely reliability. Consider a power system network wherein which there is two generator and two transformer and a transmission line bus bar, and at the two sides of the bus bar there are a circuit breaker. There is a fault here. This is a fault that is occur on a transmission line. If the system is reliable, then there is a circuit breaker connected to this faulty line has to be open first. Then this circuit is said to be reliable in nature. If not, the circuit is not reliable. Therefore, for the reliable operation, this circuit has to be open as fast as possible. Here, consider, suppose if instead of that circuit breaker, if this circuit breaker is open, then this system is not said to be a reliable one. Therefore, a system is reliable only when a concerned circuit breaker will be operate when there is a fault on the system. If not, then the system is said to be unreliable. If the system is reliable, then the whole system will be under good operating condition, and it will serve a continuity of supply to the customer, and it will provide a good operating condition. Next, completely reliability. For that, once again we will see what do you mean by complete reliability. We have considered with the example power system network, we have took that, with that we have explained the what do you mean by reliability. We will see once again what do you mean by a reliability in this Here it is explained here is that with a trend of interconnection, and the increased capacity of a generating station. One is trend of interconnection and another one increase in capacity of the generating station. With these two, we need a reliable switchgear. That is very important. With that too, with the trend of interconnection and with the increase in capacity of the generating station, these two leads to reliable switchgear. That is important, and this will improve the reliability. This will improve the power system reliability. When a fault occurs on any part of the power system, the switchgear must be operated to isolate the faulty section from a remainder section. Then circuit is said to be reliable in nature. Next, discrimination. What it has to discriminate? It has to discriminate faulty part from a healthy section. Consider a fault at this point. For the point at this section, this circuit breaker has to open. This circuit breaker has to open for the fault at this section. Instead of this section, if some other circuit breakers are open, it is said to be it is not discriminating the healthy part from the faulty section. Then it is said it is not discriminating that. They are discriminating. Then it is said that if it is not discriminating the healthy part from the faulty section. Let us quickly go through what do you mean by a discrimination. What it has to discriminate, what it has to differentiate. It has to differentiate a healthy part from a faulty section. Switchgear, a fault occurs on any section of the power system. What is power system is the one, it is a system from generating station to the load, that is called the consumer premises or the industrial needs, that is called as a power system network. When a fault occurs on any section of the power system, a switchgear must be able to discriminate between the faulty section and the healthy section. It should isolate the faulty section from the system without affecting the healthy section. This will ensure a continuity of supply. Consider what do you mean by a quick operation. That means if a fault occurs on this line, then a circuit breaker related to this line has to operate as quickly as possible in order to separate out the faulty section from the healthy section. If not, here otherwise if the concerned circuit breaker is not operating, and then the remaining circuit breaker, that is a backup protection circuit breaker, will open. This will continue. This will shut down the complete system. That is, it will endangering the complete shutdown of the system. Because of that purpose, a circuit breaker or a switchgear concerned to the faulty section has to operate as quickly as possible. When a fault occurs on any part of the power system, the switchgear must operate quickly so that there is no danger is done to the generator, transformer, distributor, transmission line, bus bar and other equipment by a short circuit current. If the fault is not cleared by the switchgear quickly, it is likely spread into the healthy part, thus endangering the complete shutdown of the system. Therefore, the switchgear has to operate very quickly. This is one of the essential feature of a switchgear. Next essential feature is a provision for manual control. A switchgear must have a provision for manual control. In the case of electrical or electronic control fails, the necessary operation can be carried out through a manual control. So that is, a switchgear has to control manually. Provision for manual control. A switchgear must have provision for manual control. In case of electrical or electronic control fails, the necessary operation can be carried out through manual control. Next, the provision for an instrument. Consider, for example, the control room that is present in a MVSS and a substation and a generating station, wherein which there is a control panels. For the control panels there is a instrument present at that control panels that will record the current, voltage and CTPT, current and voltages and frequency, power factor. All those will be keep on recording in order to observe a normal and abnormal condition among them. This will be supervise the operation of electrical equipment in the power system. For that purpose, there is a separate switchboard. There is a switchboard in the power system in the control panel in order to monitor the power system parameter. Next, we will see switchgear equipment. First, earlierly there is a tumbler switch attached to a fuse that will be used as a switchgear in order to protect the system from the faulty condition. That is, it is used in the home and offices for the protection of the system. With the advancement in the technology, next a HRC fuse is used for the protection of a power system equipment from the short circuit fault. Here this will be protect this system, the fuse will protect the system from the short circuit fault and overload. Here there is a problem arises in this switchgear, that is, we have to separate out, we have to rewire the fuse after every operation. That is, after every operation we have to rewire, and during that there is a discontinuity of supply to the consumer. And next there is a circuit breaker. This is a switchgear equipment. That this circuit breaker has a fixed contact and a moving contact that is placed in a medium, that is a dielectric medium, that is a air and oil, vacuum and SF6 gas. Here this circuit breaker will be closed under normal operating condition, and it will open when there is a fault occurs on the transmission. Next switchgear equipment is a relay. Relay is the one which will detect the fault and send a signal to the circuit breaker to open the faulty section from a healthy section. Next we will see switch. A switch is a device which is used to open or close an electrical circuit in a convenient way. Switch, here there is a two types of switch shown in the figure. One is a air brake switch and another one is a isolator switch. In air brake switch, it is consisting of a through arcing on. This is made up of metal pieces. These arcing on separate further and further if there is a opening of the contacts. Due to opening of the arcing on further and further, it will arc length will increases. This will quench the arc in the air medium. Next we will see operation of a switch, condition at which it will operate and what type it is called as, and use of the switch and application of the switch that is put in a table form. A switch is open and closes under no load, and a switch will be open and closes under full load, and it does not interrupt a faulty current. And if the switch's current, if the contact of the switch open in a air, it is called as a air switch, and it is used in a outdoor medium. It is used in a, and the application of which is that is transmission line supplying from a mains. If the contact of switch open in a oil, it is called as a oil switch. So this is used in a high voltage, high current capacity circuit. And another type of switch that is called as a isolator. It will be open under no load. This is used at both sides of a circuit breaker. This is used for service and maintenance. Fuse. Fuse is a switch gear. This will protect the circuit from a overload and a fault condition. That is a overload and a short circuit. During short circuit and a overload condition, this fuse will be operate. The figure shows a KitKat fuse. In this fuse, we are connecting a fuse wire for this session. Each and every operation of the fault condition, it has to be replaced, and it will take a sufficient time for the operation, and during the normal condition the fuse will never heat. Under faulty condition it will going to heat up. Figure shows KitKat fuse or a cartridge fuse. In this fuse, this is the point at which fuse wire is connected, that will protect the circuit from overload and a short circuit condition. Here, in which for every operation we have to replace a switch. Therefore, there is a discontinuity of a supply during the rewire operation. Here, let us see what do you mean by a switch. I have told earlier that we have to connect a piece of wire at that point. That is, fuse is a short piece of wire or a thin strip which melts when excessive current flows through it for a sufficient time. Or fuse perform both detection and interruption function. Here, observe the sentence. Here in this we have said that it is whenever the excessive current flow through it for a sufficient time, then only it will going to melt. That means it will not operate as quickly as it is not operating quickly when there is a fault is detected by heat. It will take some time in order to heat, and then it will get melted up, and it will separate the faulty section from a healthy section. Next, see under what condition, what all the condition at which switch fuses overheats and it doesn't overheats. Fuse will not overheat under normal working condition, and it will going to heat and melt after sufficient time under overload condition or a short circuit condition. Consider a circuit breaker. Circuit breaker is a one which will break the circuit under fault Under normal condition, circuit breaker is closed, and whenever there is a fault occurs, circuit breaker is open. Circuit breaker is an equipment which can open, close a circuit under all condition, no load, that is current is equal to 0, full load, that is the rated current of the equipment, and a faulty condition, that is a short circuit that is occur in a electrical equipment or a electrical circuit. And circuit breaker is so designed that it can operated manually or by remote control under normal condition and automatically under fault condition. Here one thing we should remember here, it will not operate as by itself. It will operate only when it will get a trip signal from a relay. After that it will get operate. It will detect the fault is detected by a relay, then it will passes a signal to the circuit breaker, then the circuit breaker will break the circuit. Next, there is a circuit breaker shown in the figure. This is a oil circuit breaker. It is consisting of two parts, fixed contact and a moving contact. There are two fixed contact and there are two moving contact. These contacts are immersed in a transformer oil, and there is a air cushion at the top, and the level of the oil is maintained. This is placed in a vessel, oil chamber. Here type of circuit breaker. Here the circuit breaker will open under faulty condition. Faulty condition means what? There is a short circuit. Under short circuit, heavy current flows through the circuit breaker, during which the circuit has to open. During open, there may be there is a arcing present at that time. Therefore, we have to quench the arc that is produced during that time. That is a challenging task in front of an engineer. That arc produced during the opening of the switchgear has to be quenched in a safe manner. Therefore, in order to quench that arc, we have to place the contact of the circuit breaker in a insulating media. For that, according to the insulating media wherein which we have placed the fixed contact and the moving contact, circuit breakers are classified according to which there are four circuit breakers, mainly a air circuit breaker, oil circuit breaker, SF6 circuit breaker and a vacuum circuit breaker. Air circuit breaker one which it is used in a outdoor application. Next, relays. Relay figure shows a relay. This is a electromagnetic relay. Relay is a one which detect the fault and which will detect the fault and send a signal to the circuit breaker so that the circuit will be interrupted by the circuit breaker. You should know that under normal condition circuit breaker is closed, under fault condition it will open. Here relays are one which will detect the faulty condition depending upon the following parameters. That means it will detect the abnormal condition occur in the voltage variation, current variation, frequency variation, impedance variation, power factor variation, and similarly there are other parameters are going to vary. That variation in the parameters from normal condition to abnormal condition is detected by a relay. Here, relay is a device which detects the fault and supply the information to the breaker for circuit interruption. Before going to multiple choice questions, let us briefly quick through what we have discussed in this session. In this session, we have discussed about switchgear and the essential features of switchgear and the types of switchgear. In a switchgear, what is the switchgear does? It will protect the electrical circuit and the power system components or equipment from a fault condition, and also it will switching on and off of the circuit under fault condition or a normal condition, and it will control the circuit of the power system equipment and also the circuit. Next, essential features of the circuit breaker. Circuit breaker should be reliably operated, and it should be discriminate the fault condition and the abnormal condition, and it should be quickly operated, and there should be a manual control, and there should be a provision for a instrument. These are the 5 essential features of a switchgear. Next, we will see the types of switchgear. The first switchgear which is comes to is a few switch. Switch is one of the switchgear that is occur as which is there present earlier in the earlier stages of the power system. That is at the beginning when there is a power systems network is small, and consumers are also small. During the small network and during a small power system network, and power system power capability is small and the current carrying capacity is small. During that case, we have used switches as a switchgear, that is a tumbler switch along with a fuse is used as a switchgear. And with the advancement in the technology, we have gone through the another switchgear equipment, that is a fuse where we have used a HRC fuse as a switchgear, and the advancement of technology in the field of switchgear power system, we have gone through the switchgear, that is a circuit breaker. Then we have gone through this relay as a switchgear. Now we will see some of the multiple choice questions. Some of the multiple choice questions. The first question: the main function of a fuse is to protect the line, open the circuit, prevent the excessive current, and none of the above. Here in this case, the answer is prevent the excessive current. Second question: which of the following medium is employed for extension of arc in a air circuit breaker? The answer is air. Next, relay can be designed to respond to changes in resistance, reactance, impedance, voltage and current, temperature. For all the quantity, it will going to react. Therefore, answer is all the above. Next, the function of circuit breaker is to safeguard the circuit, on and off the circuit, to save the human life. None of the above. In this, to safeguard the circuit is the correct answer. Next, circuit breaker are essentially current carrying contact called electrodes, arc extinguishers, circuits to break the system, transformer to isolate the two system. In which the correct answer is current carrying contacts called electrodes is the correct answer. We will see some of the multiple choice questions. First, the main function of a fuse is to protect the line, open the circuit, prevent the essential excessive current, and none of the above. Among this, the correct answer is prevent the excessive current. And the second question is, which of the following medium is employed for the arc extinguishing in the air circuit breaker? In the question itself there is an answer, that is the air. Next, the relay can be designed to respond to the changes in electrical quantities such as resistance, reactance, impedance, voltage and current, temperature, and all the above. All the above is the correct answer. So next question, the function of a circuit breaker is to safeguard the circuit, on and off the circuit, save the human life, none of the above. In this, the correct answer to safeguard the circuit. Next, the circuit breakers are essentially current carrying contacts called electrodes, arc extinguishers, circuits to break the system, transformer to isolate the two systems, in which the correct answer is current carrying contact called as electrodes. Sixth one, an efficient and a well designed protective relaying should have good selectivity and reliability, economy and simplicity, high speed of selectivity, and all of the above. In this, all of the above is a correct answer. Which of the following is a least expensive protection for overcurrent? Is a low voltage system. That is, rewirable fuse, a least expensive one. That is, the cost of that is very less. Next, MCB, miniature circuit breaker, protect the circuit from short circuit, overload only, short circuit and overload, none of the above. Here we are using such a type of breaker in our house, wherein which it will protect the circuit from a short circuit and overload. Next, short circuit current are due to a single phase to ground fault, phase to phase fault, two phase to ground fault, phase to three phase fault, and any of this. And in all the cases you will get a short circuit current. Therefore, answer is any of this. Which of the following circuit breaker has a high reliability and a minimum maintenance? The answer is circuit breaker with a SF6 has a high reliable in operation and a minimum maintenance. With this, I will conclude my session. Thank you.